Welcome to Fourth International Congress on Human-Computer Interaction, Optimization and Robotic Applications. HORA 2022 is organized by National Technical University, Kharkiv Polytechnic Institute. HORA 2022 is technically sponsored by IEEE Turkish section. Thank you for your scientific contribution and support to HORA 2022. If you want, let's start the session. First paper belongs to Tanupriya Choudhury. Are you ready to present?
Yes, sir. I'm ready to present. Thank you.
Okay.
Thank you for your kind invitation.
You can start your presentation if you want.
On my behalf, my scholar will present the paper. He is also the co-author for the same. He is also online. His name is Arunachaleshwaran VR. I think, Aruna, can you hear me?
Yes.
Aruna?
Yes, sir.
Okay, fine. You please switch on your camera and start the presentation. I am online. If any query will come, definitely I'll be there to assist you. And thank you. Thank you very much.
Thank you.
Okay.
Aruna, please share your screen.
Yes. Just a moment.
Thank you. You are online now.
I guess the presentation is visible, right?
Yeah, fully visible. Thank you. You may start.
Okay. Okay. Our paper is titled Quality Evaluation in GoASYNC Using Deep Learning Architectures and Experimental Review. Also, I would like to thank the HORA Congress, the panel, and
please, you have
involved.
10 minutes, okay?
Yeah,
you have 10
yes,
minutes,
sir.
okay?
Yes, sir. Yes, sir. Aruna,
Okay.
kindly
Yes.
complete your presentation within 10 minutes only. Yeah.
Okay.
Thank you. Please start.
Yes, sir. I would also like to thank everyone involved in this HORA Congress for inviting us and accepting our paper and presenting us with this great opportunity. So the motivation behind our paper is that Goa is like is a fruit, which is very commonly liked by Indian people as well as other Asian countries as well, and this can be made into things like jams, juices, and lots of things, as well as some skincare products and stuff like that. So this is a fruit which has quite a lot of impact in the food industry, like evaluating the quality of a particular Goa. The humans can do it visually, and like people are like very well expert in this, but doing this automatically is a bit of a difficult task. So that is what our paper aims to address. This would like speed up the process in like food industry, as well as could make the process a bit more reliable as well. So I'll just come to the overall methodology we follow. This is more or less standard machine learning methodology. Like we first acquired the Goa samples. The acquired Goa samples were aged around 108 to 120 days at the time of plucking, and we basically took photos of them over 15 days. We did not use anything like refrigeration or anything. So we basically let it naturally age. Once and then we took photos. Photos were taken with mobiles. One day, a Redmi Note 9, and this was done in like somewhat standard lighting conditions, but little bit of variation was there due to sunlight and things like that. So that somewhat it should look natural. That's why we did that. We followed it with by pre-processing, augmentation, and training and the evaluation. I will get into a bit more detail into these things. Yeah, so the data collected. As I mentioned before, Goa was naturally aged, so that we can also model the natural degradation, like how it would degrade if in a market situation as well. As well as I mentioned before, the age was like 108 to 120 days, and the sample was like evaluated by a panel of experts, and they followed like ISO standard for these and assigned them values in terms of like different parameters like texture, color, and shape, which I will be showing you some images as well, example. And because like the images had some background, we used like a standard COCO dataset, a masked CNN, which was trained on COCO dataset to remove the background using the segmentation technique.
Aruna, I think you are muted. We can't hear you.
Yes, we can't hear you.
Aruna, I think you are muted. We can't hear you. One minute, sir. I'm just calling him.
Okay. I stopped the recording.
I think it's fine now. Yeah,
Okay.
Please go ahead.
Okay, yeah. Yeah, and so like to make the training process more robust as well as like increase the data set, we basically performed augmentation. Augmentation involves things like rotating the images, randomly zooming in, and as well as horizontal fill. We did not apply things like crop and color and center shift and things like that because, as I said before, the classification or quality evaluation of GOA is like heavily dependent on the aesthetic features. So that is why this might introduce some problems. That's why we didn't do this thing. And so yeah, this is like an evaluation. Like GOA quality is like best in this kind of one shown on the left, and these things are like progressively getting worse. And this is basically just the same for this thing as well. The shape and texture as well, we have shown it, and this is so basically we are like assigning values in range 1 to 5. 1 being the lowest and 5 being the best for each of these attributes, color, shape, and texture for each of the images. For this labeling, as I said before, it was done by a panel of experts. They also inspected the sample directly as well, instead of just viewing the image as well, while assigning the quality class. And like we basically used a few pre-trained neural networks because as the data set was small, like only 490 images. So for that, we applied fine-tuning to perform the actual quality evaluation. So the models we tried were like VGG16, Inception, V3, and Exception. We used these models because these were explored in the previous literature as well. So we wanted to see how well those techniques were applied for GOA as well. That is why we tried these things. As I said before, like transfer learning was applied and augmentation I have explained, and we have used Adam Optimizer. Training process took place using the cross-validation, 5-fold cross-validation. And
Aruna, please inform why we have used Adam Optimizer.
Yeah, yes, sir. We used like Adam Optimizer because typically this is what is you used for these networks, as well as this is what is the recommendation for it. We tried a few experiments with other things like SGD, as well as Ada Optimizer and things like that. Those perform slightly worse than this, so we just stuck with Adam. As there wasn't much variation and the other things were performing slightly worse. That is why those results are not in the paper, but yeah. So the experiments were conducted on Google Colab using the K80 GPU, which was available on the cloud, and like standard methodology, we tested on a different data set instead of the training one, and we see our results are that VGG performs better than Inception and Exception in our case, and like Exception slightly outperforms the Inception model. So these are like the curves, model accuracy, the model loss curves, and things like these. Like this is for the shape. This is one is illustrating the same for the color. This is one is for the texture, and these are like the overall quality class evaluation metrics. We are also showing the training loss, the validation loss, the training accuracy, validation accuracy, and the model accuracy. The model accuracy here means that this is the accuracy at the testing stage. This training accuracy is the accuracy on the training dataset, and validation accuracy is the accuracy on the validation dataset. So that is the thing. As well as these are like the metrics for the prediction of individual class for a particular attribute. Like for class color, we had like these 5 values. C1 being like color is the worst, and C5 being the color is the best. For these things as well, we can make some predictions. Confusion matrix for the scheme is as shown here. Similarly, we did for like shape and texture. So this is the matrix as well as the confusion matrix, texture matrix and the confusion matrix. And so this is basically our conclusion. As I said before, VGG16K had accuracy of 84.21%, and the exception comes close with 82%, and the insertion achieves 80.42%. Like future work, like this could be more generalized. People could be using a larger sample as well as collect GOA from like different parts of the world. Like our GOA was collected from Agri-Horticultural Society, but people could collect from other things. So that the analysis becomes more robust, as well as a mobile application or a web application could be developed, so that this could be used easily. Yes. So thank you. Any questions?
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no questions. Thank you again. I wish you success in your career.
Thank you.
Thank you, Aruna, and thank you all of you for your kind gesture.
Thank
Aruna,
you.
I kindly request you to please be here and kindly listen to other participants' lectures also. Thank you.
Okay, thank you. The next paper belongs to Vincent Nyangaresi. Are you ready to present?
Yes, I'm ready to present.
Okay.
All right, so my name is Vincent Nyangaresi, and I'm presenting a paper whose title is Efficient Extreme Gradient Hosting Test Algorithm for Quality of Service Optimization in Inter-Radio Access Technology Handles. So my other co-authors are Stefano Ginjama and Jose Domain. So move on to the introduction, where we note that the deployment of many base stations within a small network coverage area can potentially increase the network capacities. But we know that this implies that the user equipment experience frequent handles as the users move within the small.
Your voice is very noisy. Please.
Okay, I'm using the earphones. Maybe I can just. Is it now? Is it now okay?
Okay.
Right. So I'm saying that we move to the introduction, where we note that the deployment of main base stations within a small network geographical area, it can potentially increase the network capacities. But we note that this increment of the base stations implies that.
Sir, sorry to interrupt. Your voice is not audible to us. If you please make loud in the system, make it more louder.
All right, then.
Yeah, kind request, please. Thank you.
Okay. Hello, are you not, am I now clear? Hello.
Okay, you can continue, please.
All right, thank you. So we note that when we increase the number of base stations within a small geographical area, then the user equipments are going to experience frequent handles as the users move within this coverage area. And therefore, an effective handle strategy is required
to boost the quality of service as well as quality of experience during the handoff process. Unfortunately, most of the conventional handoff strategies are reactive in nature, and they also deploy single or few parameters as input to the decision-making process. So our approach is to deploy the reference signal receipt power with some threshold to develop a handoff strategy that is shown to have improved the quality of service. We also use an extreme gradient boosting cluster that is trained and deployed to offer inter-radio access technology handoff prediction. So it is demonstrated that through the receive operating characteristic area that the developed classifier predicts the success of the inter-radio access technology handoffs with high probability. And finally, we show through the handover success rate that there's an improvement, and also in terms of the handover failure rates and the ping pong rates, we show that these are reduced in our proposed scheme. So we move on to the proposed extreme gradient boosting, which consists of 10 stages. And because of time, I'm not going to explain each of this, but essentially it begins by initiating some feature set as well as the sample data, after which we initialize some loss function in step 2. We execute some prediction devoid of the sigmoid function in step 3. Then we carry out some probability-based prediction in step 4. So in step 5, we derive the additive learning process, and in step 6, we derive the gradient function. In step 7, we derive the Hessian function, while in step 9, we obtain some multiplication function. Then in step 10, we derive the weighted loss function, and in step 11, we obtain the first order of the weighted loss function. And finally, we derive the second order derivative of the sec of the weighted loss function. So with regard to the proposed handoff estimation, so the process begins by initializing the number of handovers, the number of user equipments within the coverage area, okay? After which we measure the figures of merit, that is the forms for each of these user equipment. And then step 4, we determine the radio resource control event, which is basically triggered when the figures of merit from the adjusted side becomes better than a given threshold. Then in step 5, we partition these measured figures of merit into some training and test data, after which we train the learning model in step 6. And in step 7, we complete the end of execution decision HD. And then in step 9, we also derive the area under curve receive operating characteristics. So in step 9, provided that the area under curve receive operating characteristics is more than a given threshold, which is 0.7, then we deploy the completed handover decision as an application estimate of the handover execution process. However, if this is not the case, then we move on to step 12, where we deploy the reported measurement by the user equipment for the handover decision. So we move on to the results, where we use a number of parameters such as the handover failure rates, the handover success rates, as well as the ping pong rates to appraise the developed scheme. So from these figures, we can see that the proposed inter-radio access technology handover has better performance in terms of the handover failure rate when you compare to the standard inter-radio access technology. Then in terms of the handover success rate, again, we can see that the proposed scheme has better performance in terms of the handover success rate compared to the standard inter-radio access technology, as the number of these equipments in the network area increase. And then finally, we also make use of the ping pong handover states, where you can see that the proposed protocol has better performance in terms of the reduced number of ping pong rates compared to the standard inter-radio access technology rate handoffs. So in conclusion, we have seen that handoff prediction and optimization can greatly influence both quality of service and quality of experience. But most of the current handoff optimization and prediction algorithms have been noted to be only suitable in homogeneous networks and not in heterogeneous networks, that one 5G. Some of these schemes also utilize very few parameters that fail to meet the user network as well as device and application service requirements. So the proposed algorithm expanded the handoff optimization and prediction by incorporating additional parameters to enhance the quality of service as well as the quality of experience. So it has been demonstrated that it has improved the handover success rate and also reduced ping pong as well as handover failure rates. So the future work lies in the incorporation of previous and security models in these algorithms so as to preserve confidentiality, integrity, as well as availability during the handover process. So this marks the end of my presentation. If there is any question, feel most welcome. Thank you.
Thank you for your presentation. Dear participants, do you have any question about this study? Okay, no question. Thank you again. I wish you success in your career.
Thank you so much, Prof.
Okay. Next paper belong to dear Oybek Pirimgulov. Dear Oybek Pirimgulov, are you ready to present? Okay. The next paper, dear Alexander Laptiev, are you ready?
Yes.
Okay, you can start your presentation if you want.
Что такое? Что? Oh, yes.
We can't hear you. Do you start your presentation?
You cannot hear anything?
Yes.
Give a second.
We see your screen.
Sorry? Hello?
We see your screen. You can start your presentation.
You cannot see anything?
We see your screen, your presentation screen. You can start your presentation.
We started already,
Okay.
but you cannot hear us and you cannot see the presentation, yes?
No, we can hear.
Ah, okay.
Okay. Please start your presentation. Dear Alexander Laptiev.
Now you can see it?
Yes. You can start. Are you ready to present?
Yes, we're presenting, but you cannot see it, and I have no idea why.
No, we can see.
Okay,
We can see and we can hear.
so yes,
Okay, you start, please.
we started.
Yes. Please start your presentation.
We started already.
Okay.
Пускай опять.
Dear Alexander,
Yes.
won't you voice?
Sorry. One more time. What?
Won't you voice your voice?
Okay, we did the presentation. We just use the computer voice to make it more clear to everybody. We start
Your
the video.
computer voice is not here.
Our computer was where?
We can't hear your computer voice.
Oh, that is the reason. Now I understand, because we started presentation with computer voice and you cannot hear it. Now we understand what is an issue. Okay.
Please start again and
Yes,
adjust voice.
Да.
We will try to start it from again with different
Okay.
configuration. Give us like few seconds.
Dear Alexander,
Sorry,
if you
we have
want,
some technical issues.
I will take the next study.
Okay, just give me a second. I will try to read it by myself, but it will be much more slower.
Until you are ready.
Okay. Okay, now you can see the screen with presentation.
Yes.
Okay, evaluation of efficiency of application of functionality. Sustainable generally.
Sorry. Evaluation of effectiveness of application of functional sustainability generation information system of the enterprise. Introduction. The development of modern society requires the intensive development of information technology with the high degrees of autonomy. This problem is especially activity for manufacturing enterprises that operate in the forces of external factors. The enterprise, the information system of enterprise operates under the influence of external and the internal destabilization factor. And the negative effect system modulates may fail. However, the system must operation often of the specified time. This operating condition can be met by provide the functional stability preparation. The properties and application is to apply to the central method on the enterprise the properties of the functional stability of the enterprise information system by presenting the functioning of the system, the formalization process in which the main type, the process data, are the accumulation of test analysis, of test link, diagnostic valid model, the restoring the system. Basic provision, the assimilation, the mathematic modeling. To configure the correctness, the development, science, and methodological operating mathematical modeling on the process of diagnostic the information system of the enterprise that carried out. At the same time, the information system was divided to several subsystems with contained a number of modules. The technical condition of the subsystem is given in the form of binary factor formula 3.1. Assimilation made the work during the simulation. It is assimilate that computing modulation that are part to the subsystem are connected of the modules of the submission. All submission modulation are not complete related. It is assimilate that the beginning to the diagnostic property. Expression 4.1. In the algorithm of analysis on diagnostic information test result, the set level of reliability to diagnostic that it set. Expressional 4.2. The current simulation time and the diagnostic time were determined in the conventional unit of the yaw. During the simulation, it is assimilate as each model has a random volume T per which is distributed according to a uniform distribution level within the following limits expressional 5.1. Part of period of solving the main task is divided to solving service task, progressing interpaths, and the performing diagnostic task. Where the TP is the pause time with is that each module also randomly within the expression volume 5.2. The simulation of diagnostic information is modeling is accordance with the method of the conditional transmission of information. After the assimilation of information, replacing to the matrix of test result. The number of test results assimilated by this model is denoted as K pair. The essences of the algorithm for analyzing the result of inspection is to calculation to a posteriori probability of the operation condition of all models and determine the current technical condition of the subsequent models. At this point, the diagnostic procedure ends at the correctness of the diagnostic is determined by the method of comparison with the specified technical condition at the beginning of modeling. The calculation of the reliability of the diagnostic G is carried by the performed 100 times the diagnostic procedure. Error of the first and second generate variable, not calculation. By the simulation result, graph shown in figure 1.4. Fig 1, the dependence of the reliability of the diagnostic G of the number of valid models and for the condition G 0.8, 0.98. Result of system modeling with N 15 models. Fig 2 depends on the number of the check K on the number of valid modules and from the conditional G 0.8, 0.98. Figure 3, the dependent on the time diagnostic TD of the number of valid models. Figure 4 depends on the reliability of diagnostic D on the number of valid models and from the condition D 0.8, 0.98. Conclusion: the reliability of the diagnostic does not change due to no expression of the system. This is D and the property of adapted self-diagnostic. The dependent of reliability on the priori probability of the operation models on the state show a slight increase in the reliability with increasing while on the priori probability on the operation of the state. The dependence of the reliability on the priori probability on the operational models of the state show a slight increase in the reliability with increasing while on the priori probability of the operation of the state. The number of test K pair is a diagnostic parameter EQ on the number of tests result simulation in the module which will perform the algorithm of the analysis. The number of testing characteristics, the amount of the diagnostic information. The time the diagnostic TD, as well as number of check pair, depending on the number of valid on subsystem and from various exponential with a small number of values n from 0.2 n. This is the property at advantage self-diagnostic considered in the paper is the contract on the executive once they do increase in the time on the diagnostic and they expect the decrease on the reliability of the diagnostic. At the same time, at the time diagnostic predictive and the with acceptive limit with a node and the detect values in the time roll back a computational process and the enter insensitivity of the computer or process or the fault of system modules. Thank you, Antoinette.
Thank you for your presentation. Dear participant, do you have any question about this paper?
Yes, we will pass it. Thank you.
Okay, thank you. No question. I wish you success in your career. Thank you again.
Sir.
Next paper belong to dear Luan Gashi. Are you ready to present? Dear Luan Gashi?
Yes, yes, I'm present.
Okay, you can start if you want.
Okay, thank you.
You have 10 minutes, please.
Okay, just let me share my screen. Are the slides visible?
Yes.
Okay, thank you. So my name is Luan Gashi, and the paper which I will present is, its title is The Integration of Wireless Sensor Networks, Mobile Networks and Cloud Engineering for a Decision Support System, which is based on a systematic literature review. We are 3 authors of this paper. It includes me, Atan Luma, and Ilber Yanuzaj. The agenda of this presentation includes the introduction, aim of the research, research question and raised hypothesis, research methodology, findings, and conclusion. The research brings out the authors as well as their papers where the wireless sensor networks, mobile communications, and cloud computing are mentioned. The focus of the study is to define a model of integrating the wireless sensor networks data with the next generation of mobile networks, and which will be processed on multi-processed and transmitted on the multi-tier computing networks. This in order to be used in the process of decision making for critical situations. The research contributes in defining an integrated model of these technologies and shows the close relation between these technologies. The aim of research is finding out if there are enough indicators to provide a solution which is based entirely on the latest wireless communication systems. Furthermore, this will show if there is any exceptional approach to model such as networking topology. The aim of this research is accomplished by answering the research question and validating the raised hypothesis, which is done by using the systematic literature review conducted to gather and process data which provide information about the mentioned technologies. Regarding to this, there is one research question and one raised hypothesis which are part of this research. The research question intends to define what is the model of integrating the wireless sensor networks data with next generation of mobile networking and multi-tier computing networks, which can be used for the process of decision making in critical situations. While the research hypothesis is that the model for a recommender system, which transmits VSN data through NGMN, can be deployed by using multi-tier computing networks. The research methodology started by defining the research keywords, which are the wireless sensor networks, mobile networks, edge fog, and cloud computing. The search is conducted at 3 publishers' databases, which includes the last 5 years of published papers. And by this search, So the research is conducted at 3 publisher databases, which include the IEEE Explorer, Springer Link, and Science Direct. From the first database, we found out that there are 25 conference papers, 6 journals, and 1 book. From the second database, we find 94 articles and 25 conference papers, while at the third database, we found 50 research articles by using the research keywords. The research methodology then continues by extracting the data and checking the quality of those data, which is done by fulfilling the so-called critical appraisal skills program checklist, which includes 10 questions with 3 different levels. And by this first filtering, we found out that there are 85 papers which are considered as relevant papers for further study. Again, the next level of filtering papers in order to define the qualitative papers is done by selecting the most positive answers according to the test questions. And from this filtering, we have defined it that there are 34 authors whose papers are selected as most qualitative papers for our research. The table shows the respective authors. Yes. According to this, the findings of this systematic literature review finds that the research questions is validated and the raised research question is answered as well. This is done based on that the findings shows that the VSN collects environmental data which show critical situations, so they gather events from critical situations. Also, there are enough indicators which show that there can be an integrated model that transmits VSN data through next generation mobile networks, and which can be deployed by using cloud engineering. By cloud engineering, respectively, we mean the concept of multi-tier computing networks such as edge, fog, and cloud computing. This defined and proposed model is not or is partially found on referred studies as fully wireless solutions. So we can conclude that this is the gap of all those papers which we have studied. To conclude all this, in this paper, by using the findings based on the SLR method, we validate the raised hypothesis that a model for a recommender system which transmits VSN data to NGMN can be deployed by using multi-tier computing networks, in meaning of edge, fog, and cloud computing. Also, based on findings, VSN collect environment data, so this information can be used to support the decision-making process in critical situation if such sensors are installed for this purpose. The findings also show that VSN are considered as a subset of IoT, and by this have the same limitations like IoT networks. But this issue would be mitigated by using the edge or fog and cloud computing, where the next generation of mobile networks such as 5G and 6G plays the main role in improving the latency during data transmission, which is part of a limitation of VSN. Furthermore, according to this, our study contributes by defining a proposed model which is based on integrating the mentioned technologies. Nevertheless, our findings show that there are challenges regarding all these new technological paradigms, especially when mobility and security are concerned. There are several proposals intending to solve these concerns, which are mainly based on machine learning and artificial intelligence. Also, these initiative proposals show how prediction and detection can improve quality of experience as well as quality of services and can be the future topics need to be researched. Regarding to this, our next research will be on improving the defined model to be used for the process of decision-making in critical situations by using a secure recommender system in a simulated environment. So that's going to be our next research. If there is any question, I'm ready to answer.
Thank you for your
That's all.
presentation. The participant, do you have any question about this paper?
Nice presentation, sir. Very nice one. Thank you.
Okay, thank you.
Thank you. Okay, no question. Thank you again. I wish you success in your career, dear Luan Kashi.
Thank you very much.
The next paper belongs to dear Yunis Al-Safar. Are you ready to present?
Good afternoon, everybody.
Good afternoon.
Yeah, I can start my
You
paper.
can start if you want. Okay.
Yeah. Our paper is a review of multi-layer structure thin film filter in the infrared region. We study some type of paper and make this review and give some application and type for filters and the application of the multi-layer structure.
Please,
The
you have
motivation-
10 minutes, okay?
Yeah.
You have 10 minutes, okay?
Oh, thank you.
Okay, continue,
Yeah.
please.
The motivation is the multi-layer thin film structure is very promising and important structure for its unique properties such as electrical and optical properties. It is useful for both civil and military application. As we know now, the military and the civil, most application work with infrared, so we need the infrared accessories to work with infrared band. The introduction, the thin film devices are used in many optical applications, and we will mention in this review the most of them. So we study some of paper and we'll give overview for each studies. The first studies was using the thin film device in the 3D lenses which used in cinema. As you know, today there's subtype of cinema deals with 3 dimensions. So with multi-layer structure, we can fabricate the lenses to make the picture seem as a 3 dimension. Also, we can use multi-layer structure with beam splitter application. So the beam for the laser, when touch the multi-layer structure will go to the 2 ways, one for the P polarization and the other with S polarization. Also, the multi-layer structure using in the cooling of solar cell. So we can use the multi-layer structure for the solar cell to be cooled by reflect the IR and the UV band from the sun ray. As we know, the UV and IR make the solar cell with high temperature. With using this with this coating, we will reflect this band for the IR and UV, so the ray will be just the visible ray. Also, we can use the multi-layer structure in the IR detector if we want to detect if there is any IR relay in this area. We can use the multi-layer structure to fabricate the IR detector. Also, we can use this device in the filter and reflector for some light band like UV, the near IR, and the middle IR, etc. So we can fabricate a multi-layer structure to remove any part we want. Also, we can use in the solar cell itself and its accessories for the multi-layer structure. And we can use it in the laser system, nanothin film, IR generation, and malaria diagnostic device. And finally, we can collect some application like imperfect latency, film, homogeneous, enhanced photography, chemical, mechanical, polishing, optical intensity in the visible and near infrared range. Here we'll speak about the infrared spectrum. Light generation is the emission of radiation, whether it is light or
Dear Yunus Al Safar, your voice is very noisy.
Sorry. Do you hear me?
Your voice is very noisy. Can you adjust your voice quality? We can't hear you.
Yeah. Can you hear me now?
Dear Yunus Al Safar, we can't hear you. And your voice is very noisy. Maybe problem is internet speed.
I think,
your
sir,
internet
if
speed.
he is using some headphone, if he may remove the headphone and then again rejoin, this problem may not be occur again.
Okay. Try it, please. No works. Your voice is very noisy.
Internet access.
I can't understand you. We can't understand you.
Now, please.
No, there is a problem with your voice. Dear Yunus Al Safar, if you want, I will take the next work until you are ready.
Okay.
Okay. Dear Zule Ruan, are you ready to present?
Hi, can you hear me?
Yes.
Oh, thank you. Yeah, I'm ready.
Okay, you can start your presentation.
Okay, could
Dear Yunus Al Safar, please close your sharing screen. Okay.
oh, all right, thank you. Can you see my slides?
Sorry, you have 10 minutes, please.
Okay.
Okay.
Hi everyone, I'm Zularan, the speaker of our paper, Automatic Generation of User-Sensitive and Application-Sensitive Self-Adaptive UI System for Smartphone Applications. And this is the outline of today's presentation. Okay, so first of all, introduction. At present, touchscreen devices have been widely used in people's daily life and laid a foundation for the application of touchscreen interaction. So how to make users naturally and efficiently recognize content of interfaces and make right operation excuse me, is an important subject in the field of human-machine interaction. Which I believe in AUI, which is adaptive user interface, is what we need. And then adaptive user interface is a user interface which changes its layout and elements to the needs of the user or context, and is similarly alterable by each user. And the properties of an AUI creates less confusion for less experienced users and provides ease of access throughout the system. Well, research on self-adaptive user interfaces can be basically classified into two kinds. One is context-sensitive adaptation, and another is user-sensitive adaptation. And current AUI research has a lot related to context-sensitive adaptation, so I decided to research from a different angle. And for implementation, my research can be divided into 3 steps. So firstly, we collect both user adaptive and application adaptive data. And secondly, we generate movement rules based on these data. And at last, we generate the final UI screen by moving widgets based on the movement rules. And there are 2 target test application, a simpler one and a relative more complex one with more widgets to interact with. So this is an overview of our proposed system, aims to provide more comfortable user AUIs. In this example, a smartphone application called Counter is used as an example of AUI. So basically, users can interact with this application to count numbers. And this figure shows an example of the initial screen and final screen before and after applying the method, respectively. So before using our system, widgets are distributed across the screen according to the initial design of the application developer, as shown in Part A. Although the initial UI layout is stable, it is not the best arrangement for every user. So the most suitable layout will depend on the user characteristic data, which varies by the user. Therefore, our system aims to provide adaptivity to an application. So Part B shows the possible outcome after applying the system. And this figure shows the overall structure of my system. There are 2 types of actors in the system, application user and UI designer. The application user is a person who is actually using the smartphone application and wants to have a customized UI that is more suitable. And the UI designer is in charge of analyzing and defining widgets information for various applications. And there are 3 kinds of inputs in order to generate the according widget movement rules, which are the user characteristic data of the application. User plays a whack-a-mole game, and the results of widgets analysis data performed by the UI designer, and at last the usage data of the target application that the application user defined. So the output is the widget movement rules for the given application. And then in my system, to add more joy, I have written a whack-a-mole game, so the moles show up randomly, only one at a time, and the users are required to play the game. And by playing the game, the average reaction speed of pushing an icon on different areas of the screen could be obtained, and the program retrieves the number of pushes and calculates the average reaction speed at each position, which is an important and user adaptive characteristic data. Excuse me. And for application independent adaptivity, it can be divided into two parts. One is widget analysis performed by the UI designer, which is with the initial screen being displayed, and another is that the application user provides the usage of the target application. So the data collection of these two parts will be realized through a widget defining program. And here are the details of the widget defining program. It will automatically detect all widgets and pop out some drop-down selection menus for users to choose widgets type and areas, values, so on. And also on the right side, there is a grouping screen to let the users select what widgets belong to one group, thus being moved together. And this figure shows the general flow of applying the movement rules to widgets. So first of all, we calculate the next best destination of the widget to be moved, and then we check if there is an overlap with other widgets. If the answer is no, next we check if the next condition is fulfilled. If the widget moves to the destination, will it violate its original area restrictions? Will it go off boundaries if we move it to the destination? Or any of the answers being no will lead to no movement. And otherwise, we can get to the final goal where we can move it to the destination. And also, in another way, if there is an overlap with other widgets, then we calculate and compare their priority values. And if the overlap widget's priority value is greater than the widgets to be moved, then we make no movement. But if the widget if the priority of the widget to be moved is greater than or equal to the overlapped widget's values, then we try to make minimal movement to the overlapped one until it has no overlap, no violation towards area restrictions, and inside the boundaries. And thus we can move the widget to its destination, and the overlapped one will be moved nearby somewhere fulfilling all restrictions. Okay, so for evaluation, to evaluate the satisfaction of the proposed system, a combined questionnaire is being used. So several popular psychological questionnaires were used to provide researchers with a validated instrument for conducting comparative evaluation. But each questionnaire has irrelevant, unhelpful aspects regarding our research objectives. So I have carefully selected out relevant ones to merge into our final questionnaire, as shown in the chart here. And participants were divided into different groups to record the satisfaction rate towards one simple app and a relative complicated one before and after the proposed system has been applied. Okay, for the results, we statistically analyzed the questionnaires and converted them into graphs. So this figure 17, highlights the total subject response score by question for application 1, a simpler app. So for question 10, 14, 15, and 16, the subjects did not notice changes after the system update, and for others, the subjects believed that the changes improved the application. And figure 18 covers the total subject response score for each subject across different questions in the questionnaire for application 1. So for most subjects, the score differed greatly before and after the system changes were made. So in general, more subjects were satisfied with the adaptation. And based on the analysis of the collected data and comments from all subjects, the perceived improvement can be categorized into two main reasons. First, the adaptive system allowed for a more efficient user interface than the original one. And in addition, the adapted application provided more fun and interactivity. And then this figure 21 showed the total subject response for each of the questions before and after the system update for App 2, a more complex one. So more subjects believe that the changes made the application worse. And most questions had a lower score once the system was applied. And figure 22 shows the total subject response score by subject for all 21 questions before and after the system change for App 2. And the subject believed that the application was better before the system change. And most questions had lower score once the system was applied. Based on the analysis of the collected data and comments, the reasons for perceiving a poor application can be divided into two categories, and the complex application adaptivity makes the hard to remember organization of information even harder, which reduce the operation efficiency. And in addition, a more complex application means more widgets. Hence, moving many widgets at the same time without asking in advance is unacceptable for many subjects. Okay, for the results, from the statistically analyzed graphs, we can conclude several results. First of all, for a simpler application, a majority of the subjects liked the adaptive system. This is supported by the figure 18 and free responses. Most subjects commented that the adaptive system allowed for a more efficient user interface than the original one. And the aspect that was most satisfying was that it allowed for efficient operations. And the subjects also found it fun and interactive. But for the more complex application, most subjects were unsatisfied with the adaptive system. This is reflected by the fact that the user interface received higher scores before implementing the adaptive system. So figure 22. And in the future, it is imperative to expand the sample size for a more multi-phased evaluation result. In addition, the system should be investigated using more diverse applications to explore its applicability in accordance with the questionnaire results. And additionally, a simpler application may be a better target in the near future. And that's all. Thank you all for listening. Do you have any questions?
Thank you for your presentation.
Thank you.
Dear participant, do you have any question about this article? Okay, no question. Thank you again. I wish you success in your career.
Thank you so much.
Next paper belong to Neko. Are you ready to present? Dear Neko. Are you ready to present? Can you hear me, dear Neko?
Hello, do you hear me now?
Hello. If you want, you can start your presentation.
Hello.
Hello.
Hello, do you hear me now?
Yes. If you want, start your presentation.
Okay. Okay, let me share my screen.
Okay.
Do you see my screen?
Yes. Please, you have 10 minutes.
Okay, thank you. Thank you for the opportunity to present our research on indexing information in parking guidance information systems. Here is outline of my presentation. First, I'll show what provoked our research. Then I'll make a short review of what parking guidance systems are and what is their main purpose. Next, I'll show you how CBR methodology can be used to solve some problems in the context of parking guidance. Case retrieval is one of the main activities used in CBR, and our research is targeting exactly the related issues. We have compared the performance for data operations for two index types. And finally, I'll make conclusions. First of all, I want to show you what is the problem and we are trying to solve. And we are talking about parking processes in transportation and their organization. Parking facilities management could be a problem in big cities. Searching for free parking spaces could cause a lot of bad effects, for instance, congestion and extra traffic, also called hidden traffic. Also pollution. Know that worldwide statistics show average time for searching a free lot of approximately 8 minutes. A large risk of accidents and also stress into the drivers. Drivers have to take the best decision quite frequently without any knowledge about parking infrastructure and free spaces. Good decision serves not only their needs, but common needs of all participants in the process. Although some systems may provide a lot of guiding information, there are always chance some additional information to be out of scope. For instance, there could be traffic jam or road repair, which may enlarge the time vehicle will reach the parking place. This way to change the initial plans. Case-based reasoning is artificial intelligence methodology that provides solutions based on previous experience. Using this technique, we can prepare recommendation based on all previous experience. Let me briefly describe what is the purpose and structure of the parking guidance system. Generally, it provides the drivers information about parking occupancy and points to free zones where they can find free places with a great probability. Parking guidance services include providing pre-trip travel information, also travel services information, travel demand management, and traffic control. There are 4 major components of parking guidance information system. There are information delivery mechanism, information collection mechanism, information control and processing, and intercommunication network. Why case-based reasoning can solve issues in a parking guidance information system. Compared to traditional expert systems, CBR stay in the middle between open model data retrieval and closed model of expert system. Compared to expert system, case-based reasoning system do not rely on hard-coded rules defined by a specialist. Case-based reasoning system does not require effort from both domain specialists and knowledge engineers when change need to be applied in the system. Usually only the domain specialist effort is enough for this. Classical database technologies can retrieve information that exactly match the query performed by user. Case-based reasoning system find cases that are similar but not necessarily identical to searched. And also they apply some more activities than simple information retrieval. So CBR is somewhere in the middle. It resolves problems, but it is not a classical expert system, and it uses stored data for previous experience, but does far more than simple information retrieval. Generally, providing free parking space is a planning task, and because one of the main CBR usages is for planning, we think that CBR can be very helpful in solving parking guidance problems. Case-based reasoning is very similar to human reasoning when finding solutions. Popular description of this process is using the 4 R's: retrieve, reuse, revise, and retain. Retrieve step is the most similar to our new problem cases. They are searched into a case data store. Next, the reuse step makes an attempt to solve the problem with using provided on the previous step existing old solution. And then on revise step, we make analysis of the proposed solution, test and evaluate it for a success, and if necessary, adapt it for the new problem. When solution application is finally confirmed, we can retain it into the case store for further usage. Finding appropriate case in the case base is always related to description of the case. Mainly case description consists of problem related to some goal, solution, or outcome. In the parking context, problem and the goal description. In the parking guidance context, it can be described with vehicle location, final destination, length of stay, parking costs, and etc. Finding free space at a normal cost and reasonable time near to the final destination is an obvious goal of our case. Solution provided by the guidance system is a prescription in a form of actions list provided to the driver in order to find appropriate free parking place. And finally, outcome of the solution is related to final result, either successful or not successful parking. Changes also in the final recommendations may occur in order to reach goal and get specific outcome. Parking case retrieval is the main topic in our research. In many researches, CBR is specified as a lazy learning method, which means there is no preliminary hypothesis for classifying new cases. Classification for the new case is done based on all existing previous cases. On the other side, searching information in the case base is related to indexing this information. So we try to answer question, what is the main difference between indexing and classification? And does this difference do matter in case of searching for parking cases? There are distinctive differences between classification and indexing. Regarding the data they use, classification uses only the training samples to build a hypothesis, while in indexing we need the whole data set to build the index. Regarding identification of the queried object, classification attaches the object to a class of other set of objects. The index tries to perform exact match. Regarding the data not present in classification, we use inductive bias to classify data not present. And in indexing, similarities are used to retrieve data that approximately match the query. As long as in CBR, whole data set is involved in the classification each time, there is no big difference what approach we will take. Actually, the most used approach in CBR classification is car nearest neighbor, but we think that R3 index can behave better in case we have only numeric data in several dimensions. We have also reviewed other spatio-temporal algorithms like Quad-tree and Octree, but their possibilities to work only in two-dimensional and three-dimensional space limit the possibility to have more dimensions, as in parking guidance case. Query the data for previous cases is done using, actually, in most simplest case, 5 elements. Provided the picture is two-dimensional projection of the query space, excluding time coordinate. This moment snapshot of the situation. We have current vehicle location, current time at the moment of performing the query, and target destination. To find similar cases, we introduce a difference, a delta, to be applied to the queries. Also, we have in mind that in Car-nearest neighbor and Archie, they could produce different results when using same delta. And this is because of the different shapes both algorithms use. Hypersphere for Car-nearest neighbor and hyper-rectangle for R3. Anyway, here we can cover results for the other methods by enlarging the deltas, so the figure of the method we use circumscribe the other method shape. Applying this, we can have more results than expected, but for sure we will have results of the other method covered. We also measured the performance in some indexing operations for both Car-nearest neighbor and R3 applied to parking queries. Elements addition is quite fast for Car-nearest neighbor, as there is no any additional operations applied to new coming elements. For R3, we observe larger times for addition, and this is because of the tree structure used to store the information. Anyway, the delays are not so big. We observe almost linear enlargement in time. Thousands of records can be stored within milliseconds. In search process, the times needed by R3 are far better than those needed by Car-nearest neighbor. Searching in R3 is much faster. Actually, Car-nearest neighbor searches took quite a long time in order of seconds, and this is due to comparison of query elements with all other elements stored in the base. And finally, retrieval of previous experience stored into the cases database is important task for the whole case-based reasoning process. Car-nearest neighbor classification algorithm is widely used for searching similar cases, but not very well performing when we have big data and need to respond in real time. We used and measured performance of spatio-temporal indexes, and especially R3 in case of using CBR for parking guidance system. R3 performs much better in searching for cases scenario. Car-nearest neighbor operations like addition, modification, and deletion do not outperform R3, so we can better use R3 in real-time systems. As a future research, we need a way to adapt cases stored in the case base so they fit the real needs and give the best solution to each driver. And although we target every participant in the process individually, we think there is a need to coordinate all provided prescriptions and also lower the competition for the free spaces. That's all for me. Thank you. And if you have any questions, I'll be glad to answer.
Thank you for your presentation. Dear participants, do you have any question about this paper? Okay, no question. Thank you again. I wish you success in your study. Dear Ioannis, are you ready to present?
Yes, I am ready.
would you like to complete your unfinished presentation? You can
Okay.
start your presentation.
Okay. Okay. I will start from here.
Okay.
Do you hear me good now?
Yes.
Yeah. Okay. Yeah. Here is the infrared spectrum technology. So first we must know the infrared spectrum. So as with the light generation is the emission of radiation, whether it is visible light or ultraviolet ray or infrared ray. So the radiation occurs as a result of electronic excitation in device or the substance itself. So as we see here is this is the band for the UV and X-ray, gamma, infrared, microwave, radio. Also, we can see this, yes, we can see here is all the band for the visible, ultraviolet, near IR, mid IR, phi IR, and extend IR. As we see here, the ultraviolet start from 10 to 400 nanometer, the visible from 400 to 800 nanometer, so on for the near and mid and far and extend infrared region. We would talk about the infrared filter. The infrared filter are used to help filter out certain wavelength of infrared device. To reduce the high temperature effect, we can design the filter to make it reflect the infrared outside the required range instead of observing as explained in below picture. For any designing for the filters, we try to make the filter reflect the unwanted band, not observe it. Like this example, as we see in here, the unwanted band here is reflected, not observed for in the filter. Now we'll talk about the filter type. We have two types of filter. The absorption filter. The absorption filter is absorb the infrared band. The properties of some material depositing is the absorb light of certain wavelength. These filters are called the observation filter, and the wavelength range are determined by molecular properties of the participate material. As we see in this picture, the light with incident to this filter was observed by this filter and transmit the wanted IR light. The second type of filter is the multi-layer structure filter. This type of filter is reflect the unwanted band, not observe it. So the second way is to design the infrared filter is by using multi-layer thin film structure, where this method and based on the correct design use the reflection and refraction of infrared ray between the boundaries separating the thin film filter. This is the structure for the multi-layer thin film. So we can see there's many layers for the incident light. So the incident light will see many layers on his way, and the unwanted ray will reflect as we see here, and the wanted ray will transfer to the device. So every layer have an refractive index different of the next one. So the boundary will be high index with low index, and according to the Snell law, the light will be refract or refraction. The multi-layer structure have many applications. We will mention some of them. We will try to focus on the main idea of using the multi-layer structure. Here in this example, we will see IR detector as shown in below picture that the toward realization of back incident optical polymeter using the germanium with magnesium and carbon and nickel and oxygen. The thin film produced by chemical deposition technique on the oxide aluminum substrate. So this is the filter which used in this application. The second application for the multi-layer structure is the IR reflector. So using distribute Bragg reflector by emerging amorphous SiO2 and nanocrystal, it's shown that the SNTIO film exhibiting high scattering in the UV visible range that could be good for building distributed Bragg reflector working at near infrared region. As we see here, so this filter reflects the UV and the visible and transmit the IR region. Another use for the IR, for the multi-layer structure is the infrared filter. As shown in the figure below, there is a realization of the Fabry-Pérot filter for real-time monitoring photochemical reaction. As we see, the chemical liquid enter from this side and exits from this side. And we will apply the IR on this substrate, and we'll see the exist IR, and we know the state for the chemical liquid. Here we have the anti-reflection coating method. It's contained from 3-layer wideband anti-reflection coating with transmitting up to 100 at the same time at 3 different wavelengths. So this type of filter is work for the 355, 332, and 1065 nanometer. As we can see here, it's transmit the wanted band, as we mentioned below, as we mentioned for these 3 bands, and reflect the other. Here we have the IR detector. This is the IR detector. As we can see, it's contained from 3-layer containing by this way. So this is the lithium, and this is a silicon, and we will use this one for IR detector. The other studies was on the ultra-wide range measurement of IR thin film filter, the optical density broadband measurement of multi-layer thin film filter over the visible and near infrared region. As we can see, this filter is transmit the IR and visible in this side and reflect the other band in this side. Also, we have infrared detector application. As we can see in this picture, high morphological and structure quality for the BBSE structure via chemical deposition toward infrared detect system. As you can see here, this filter detect this band only, and to detect if there's any infrared ray or not. Here's some paper we studied it and put it in this form to see what we do for this paper. So we can, this is the application used in the 3D cinema or beam splitter, IR filter reflector, IR mid-band and filter, IR mid and filter, mid filter, solar cell and lenses, laser system, and diagnostic devices. Conclusion, different method and charm of multi-layer structure were proposed and investigated, last decided because of the importance of their new properties. The optical properties in the infrared region were the essential approach of conducting this study. Multi-layer structure could be fabricated on different type of substrates. A glass substrate was perfect, especially if the transmittance is required. The thickness of the layer can be an important role in the optical properties of the final structure. Moreover, the material used in the design multi-layer structure for optical device may play a vital role in many applications, such as optical filter. Thank you, and I'm ready for any question.
Thank you for your presentation.
Thanks.
Dear participants, do you have any question about this study? Okay, no question.
Thank you.
Thank you again. I wish you success in your career. Yes, Thank you to all the participants. Dear participants, I would like to end the session. I suggest you attend the next sections. See you in the next sections. Goodbye.